This animation explains the working principle of the nitrogen generators. The pie chart on the left shows each of the 6 stages of the nitrogen adsorption process. The first part of the installation is an air inlet vessel filled with pressurized air at 8 bar. Air normally contains 20.9% oxygen molecules and 79.1% nitrogen molecules. After the air inlet vessel, we enter the nitrogen generator with its 2 adsorption towers A and B. At the start of our animation, both towers are at equalization pressure of 4 bar, half the pressure of the air inlet vessel. As the generator absorbs the oxygen molecules, nitrogen, our end product, enters the nitrogen outlet vessel, currently filled with nitrogen at 7.85 bar. In this case, 0.5% of the oxygen molecules were not adsorbed, resulting in a purity of 99.5%. During the pressurization stage of Tower A, the pressure in Tower A will increase to maximum working pressure. As the pressure is initially lower than in both the in- and outlet vessels, pressurization occurs from 2 directions. Air from the inlet vessel flows to the bottom of Tower A, and nitrogen flows from the outlet vessel to the top of the tower. To allow this, inlet valve V1 and outlet valve V7 are open. While Tower A is pressurized, the pressure in Tower B decreases. This tower also started at 4 bar, but by opening blow-off valve V5, Tower B is connected to the silencer and will go to atmospheric pressure. Due to this pressure relief, the adsorbed oxygen molecules get released from the adsorbent. When Tower A reaches its maximum working pressure, in this case 8 bar, only fresh air from the inlet vessel flows to the bottom of the tower. The oxygen molecules get absorbed while the nitrogen molecules pass to the top of the tower. As time goes by, the adsorbent gets saturated and no more oxygen molecules can get adsorbed. The increasing saturation of the adsorbent is visualized by the red color within the tower. When Tower A is saturated, Tower B needs to take over. To make sure that all oxygen molecules in Tower B are released, a small portion of the purified nitrogen will pass through purge nozzle N1 to purge out remaining oxygen molecules to the atmosphere. Before Tower B is fully ready to start adsorbing, the pressure in the tower needs to increase. In the equalization stage, all in- and outlet valves close and equalization valves V3 and V6 open, connecting both towers. The high pressure from Tower A will flow to Tower B until a balance is reached, in this case at 4 bar. During equalization, no nitrogen can flow to the outlet vessel. However, nitrogen can still be consumed from this vessel, resulting in a slight nitrogen pressure decrease. After equalization, Tower B is pressurized to maximum working pressure, again with pressurization from both top and bottom. When Tower B is fully pressurized, Tower A is at atmospheric pressure due to the opening of blow-off valve V4, and the whole process is repeated. Tower B starts adsorbing oxygen molecules. A small portion of the purified nitrogen from Tower B is purged over nozzle N1 to release the remaining oxygen molecules from Tower A. At the end of the adsorption phase of Tower B, the adsorbent will be saturated and a switch to Tower A is necessary. Before this can be done, both towers will pass the equalization phase again. A full adsorption cycle consists of 2 adsorption phases, one for Tower A and one for Tower B, with 2 equalization phases in between. This process is called pressure swing adsorption. Pressure is the driving factor to get the oxygen molecules adsorbed by the adsorbent, but due to saturation of the adsorbent, the generator swings between tower A and B.